There we go. Alright. Let's just hop right into it. Continue following size 4 hot springs if you can come across an observatory. An elf within turns out to be a researcher studying cosmic expansion using the giant telescope here. Doesn't know anything about missing machine parts, only visiting for this research project. Confirms that the hot springs are the next closest area likely to have people. Maybe we can help with this analysis to speed up. Your input is a sparse map. The sum of the lengths, the shortest path between every pair of galaxies there's to catch. The unit expanding in the time it took the light from this galaxy to reach the observatory. Something involving gravitation effect, only some space expands. Sure. Any rows or columns that contain no galaxies should actually be twice as big. 3 columns and 2 rows need to be twice as big. Okay. There's 36 pair, only 20 pair once. Order doesn't matter, find the shortest path. So then you just take Manhattan distance. Yeah. Yeah, it's just Manhattan distance. Okay. Doesn't look too tough. I had a way to actually switch between these a little more easily by doing this. Ooh. Let's see, new file, D11 tests. I don't have like a massive amount of time today, so we'll just see how far we get today. I'm like 99% sure that I won't be able to catch up before the end of the year. You are so. I have driving lessons later today, my man. I actually can't. Let's see. So basically, what I do is I just get a coordinates. Best driving lessons don't. Yeah, I just do it on the Russian style and just bribe them. Oh, it doesn't get icy here in winter, so that doesn't really matter. 1 second. That's what I did, except I don't drive anyway. Yeah, I know. Alright, let me see. So my thinking is... So, you can do it 2 ways. You can just first map the whole thing, just make a sparse map, and then check if there's nothing in there. What you can also do is just... which is like not too difficult. You can just like make a dictionary or whatever, you know, a list out of them. Then grab the X's and the Y's, yeet it into a set, and then you know if you're past this, you just add it on. Can I grab this again like this? Yay! There we go. Basically, you go here, you say, okay, this one has 1 empty column in front of it and 0 empty rows, so this gets shunted over 1 more. This has 2, so it gets shunted over 2 more. Right? Because here there's 3, and then there's 4, and then there's 4, 5, 6, 7, 8, 9, whatever, and then it should be 2 more. So it'll be like, yeah, 1 extra for this, 1 extra for this, but not extra for this. And that should work, and then you just get the new coordinates, and then you do the same thing as before. I think that's the easiest. It's a little clunky. The other way would be to just physically expand it inside the map. But that would be kind of clunky, because you'd have to shift everything over. It's just that you'd have to do a bunch of loops here. Like, I'm not... Because if you do it point by point, you kind of have to, like, count every time. It's like, it's not difficult. I'm just thinking of a smarter way to do it here. Just a few nested loops and it'll be trivial, because it's always going to be fairly small. Like, I don't know what the input is. But, yeah, even this is not going to be too bad. But it's not going to be great either. So I think mapping the empty rows and columns might be easiest. I'm thinking checking if it's an empty row using, say, regex is trivial. Pretty sure it's also trivial to do without regex, because you can just do, like... Can I do, like... I need to remember to do this. Can I do... Spending more time thinking... I know, because I'm, like... At this point, it doesn't matter how I'm actually, you know... How fast I am, so I'm just gonna see if I can do this in a fun way. Yeah. And then if I do it like this... False. There we go. Let me see if I can do some slicing to do it a different way. I could do it if I'd make it into a NumPy array, but I'm not going to do that because that's actually horrible. Alright, so stars equals... I know it's not stars, it's galaxy, but it's whatever. Yeah, let's just... Okay. Y, comma, line in... Let's just do my first idea for x, comma, c in enumerate line if c equals hash stars dot append x comma y. Too much shit because I'm dumb. I'm like 99% sure that my delta is gonna be ass. I would love to keep the number 1 there. I'm not gonna aim for it. Also, because I know that there might be a day that I just can't finish part 2. Like, I would like to do whole days, but we'll see. Because NumPy is cheating. The thing with NumPy is that it's super powerful, but it will require some work to finesse your data into the structure, and it feels a bit like cheating sometimes. I prefer to use just native Python. It's not... I don't think NumPy is automatically import.solution, but which day was it that I kind of fucked myself? Yeah, like here I kind of fucked myself because using NumPy, right? Like this, with NumPy, this was a cleaner solution. It's a bit of a shame that I couldn't finesse it into something neat for part 2, but you know, part 1 was really neat. This is like horrendous to read. But for me, the fun here comes from doing it on my own. The reason that I use diff here is mostly because like, hey, I know exactly what to do here. It's trivial. I know a function that does this for me. Exactly, it was lovely. It's fucking horrible. It's like me trying to like do it the intended way and then not realizing you could just reverse the input and do it that way. Oh, it was stupid. I'll take any. Yeah, but you're doing it in Fortran IFT, so I think that's already a massive difference. Yeah, exactly. Yeah, so one thing that I was thinking of doing here, so then I can do something like, you know, x's and y's by doing zip stars. Oh, can I do this in a really disgusting way? Yes, fuck it. Let's go, baby. Hell yeah, baby. So now we have all the unique X and all the unique Ys that there is a star on. And then I could just go through the coordinates and see, you know, how many are below its own coordinates. But I'm not sure if there's an easy way to do that. That's what I'm kind of thinking about. Because I'd like to do things in a neat way here. This, I think, is fine. Ambiguous fairy. Ah, guys, shut up. So the reason why... So, just in case you're confused. So stars is a list of every XY coordinate. Doing this just puts them all next to each other. It kind of rips away the outer layer. And zip then just takes the first element from every single array, and then the second element for every single array. So just first the X coordinate and then the Y coordinates. We have to do it to a list because it otherwise just produces a sort of generator. And then, so this is first all the X's, then the Y's, and then I make it into a set to strip away the duplicates. And so here, I'm thinking about how we can do this. Because you can't, in a set, you can't iterate over everything. I could just cast it to a list again. Doesn't star for star intake generators, though. I think it might actually. Ah, you're right. I've had some issues with that before, so I'm always a bit careful there. Because if you say, try to just print this, it'll just give you a generator object, and that's a massive pain. Failed stream title? Why? Did I not click update? Should say date. Oh, because it's day 11. Whoops. I'm sure you'll survive. Day 10 is not inclusive. What if it is? Yeah, so we have a certain coordinate. I just need to count how many of them are in front, right? So let me just... Yeah, so 0, 0. This is going to be a myriad of... Alright, so... Here are the stats for the day stats of the days you missed. What? Oh, 18 doesn't count because that's today. That's a drop, man. Oh, I know day 12 star 2 is a mess. I read through the Discord, of course, to see what you guys were talking about, and the day 12 seemed like a massive pain in the ass. I didn't check any of the spoilers, but I'm very curious. Alright. So what I do then... So I need to remember to minimize this, because then it automatically does this. Yeah, I know, it's just me being... I didn't write anything. Alright. So technically what I need to do is say, okay, so we have X, Y, and stars. So sort of like a count, or like oh no, I can do something like so here becomes the issue that I can't use as a list. So let's actually do it like that. So let's just this is not nice, but fuck it, who cares? So what I can do now is I do so let's do SX and SO for those. So 1 for X in X's if X is less than star X. And then we just do a sum. So and then the same for SY. Yeah, so it needs to be less, right? Yeah, so not less or equal. Don't worry, I'm not doing anything. Alright. This I think should work, and then I need to do expanded stars. Or I could just do stars. No, I need expanded stars. Dot append. There we go. Which I could just do like this. Oh yeah, whatever. Let's see. I could just make this a list comprehension, but I'm not going to do that because that would actually, would that be too bad? There would be something like that's actually not even too bad. Right, yeah, so you count the amount of that's less, and then here, and that should be fine. Dun, 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 dun. Let me see if I can do a quickly print fields. Bah. I should, okay, let me actually just grab. Didn't I have a function here that was like print goal? Did I remove that? Probably removed it. Because it was actually kind of a nice... I really need to make that proper freaking... why not do it now? Here we go. OBS preview on your second. I already have it. I just keep forgetting to properly do that. To actually have it show. Let's see. Let's see. I want to like something like a default. Let's be like ba ba da ba ba da. I don't want it to be a set, I want it to be a tuple. Let's see here. It's, oh yeah, because it expects a dictionary, but I want it. Yeah. I'm wondering if I can. I should be able to make this a generic. Nah, but this is for a dictionary. I wonder if I can like. Does it have type overloading? I don't even remember if Python has that. I'm not even sure if it does. Day 10.2 broke me. I'm doing day 11. Day 11 though. Oh, jeez, yeah, sure. Because I do. Can you do min on a set? I'm pretty sure you can. No, because it won't be. If x comma y in states without usage. Okay, then we just print lists, print dict, whatever. I know it looks a bit horrible for you. I'm just going to compare these real quick, side by side. What's the expanded one? This. And that is incorrect. Because it adds a line, it adds this line, which shouldn't be there. Oh, of course, because I'm checking if there is one, even when there isn't one. Yeah, bah, how do I, what, fuck. So I need to check if it's not in there. I'm stupid. This is counting how many galaxies there are. I could do something like, oh, just do like x minus, because it would be, so if the position is like 5 and there's 3 before, I need to add 2, so it'd be the position again minus this. So it'd be 2 times minus this. I'm pretty sure I'm gonna get off by 1 errors here. Again, just comparing it. That looks to be correct. That looks to be pretty correct. Right, so then I just do just Manhattan distance between each pair, right? think I can just do permutate 2. Oh, what is not? It's not called pure permutate. It's like Python. Not product. No, it's like it's permutation of list, but there's like it's not called permutation because you want to do only 2. And it's called slightly different. Is it product? Now we're doing an import solution. Yeah, it's called intertools, but there's like a few few versions of it. So many of them. Common rhetorics, product. Combinations, I think it's that one. Yeah. So instead of R-led combinations in the iterable. Combinations range 4, 3. Yeah, so this is what I want. So this will be expanded stars, and they just want 2. So for pair in pair. So now we get all the coordinate pairs we want, and this should not have any duplicates in it, right? So 9, 1 should never be combined with 4. So the last one should only be inserted once, yeah. Because it'll have everything else. Can't even write 2 for loops. Yeah, but you'd have to remove the duplicates. I don't want to do that. So this is just Manhattan distance, which is just A minus B plus the other one. Absolute. Divide answer by 2. I don't want to do that. All right. Seven 4 looks correct to me. Yeah, that'll also work, but I don't want to do that. This is easier, lazier. Let's put it that way. See, the thing is, I used to just do that automatically, but just capturing the desktop browser, but I don't want to do that anymore. And it like semi-automatically does it, but only if I think about doing it properly. Much older, much farther apart. Instead of the expansion you did before, make each empty row column 1,000,000 times larger. It should be replaced with 1,000,000 empty rows, each empty row is 1,000,000 empty columns. Okay. So, you see, I keep doing it the wrong way. So now it's 1,000,000. 1,000,000! Oh, I can actually do this real quick to test it. So this should just not be 1, but it should be 100. Okay, that's not right. No, because it's because now okay, so now I should just do. So this is the original plus SX minus this. That's why. Because this is the amount of times that we expand, and normally it'd be 1 times. And now it should be the same answer as before, 374, and now we do 10. 11, 12, that's not right. Now we're getting to off by 1 errors, I'm pretty sure. Then 30, and 30. So 99, 84410. Yeah, right. Seems right. Now it's gonna be 1 million. Oh. Oh. Ah, fuck. Sorry. Here's the answer. So just do 1 million minus 1. So this is the same. And just, oh yeah. I mean, that's why you test, you know? Actually, let's do like just, yeah, whatever. Just get the answer here. Oh, yeah. Yeah, I know. Really in the elements. So this should be like states. Better than you, most likely. We'll see in a second. Nice. Yeah, pretty clean solution. I like it. Right, let me take a look what you did. Day 11. Oh, wait, no. Here. Yeah. Pathetic. Why? Because I was testing, that's why. 2 minutes 30. How the fuck did Fusion get 40 minutes? Jesus Christ. It's galaxies and not stars. Oh, I really realized that pretty quick. I mean, the whole thing is a galaxy, and the individual things are... Oh, it's even galaxy. Oh, yeah, I realized that earlier. I was like, it can't be ours to actually change it. I mean, this is not going to be any useful right now. As panic fear of 2D maps. What a guy. Didn't understand the million minus 1. What a guy. 12 is 2 hours. Okay, I have about 2 hours left, so oh, but day 12 is horrendously tough from what I remember, right? Maybe I should just do day 13 then? Because I have about 2 more hours until I have to go. You can read 12 and do 13. Oh, yeah, that's true. I'll just read 12. That's very true. Should look at my date. Fine. This is your Rust bonus. Day 11 Erlang. You just had to. Oh, you call solve, right? P2 magnitude. Yeah. That's actually kind of neat. Yeah, so it's just list comprehension, basically same thing that I did. You get the max, reduce using max. Find empty space. Let's see, what do you do then? You take all the galaxies and the axis. V, just a maximum value, is non-empty. Some distances is the final thing. And that count, yeah, that does count empty space. So find empty space just gives you a true. So list of coordinates. Yeah, because if there's something there, it's not empty, then you just keep going with the same one, and if not, then you discard it. Yeah. And you check the other position. Yeah, because you go from the max to down. Yeah. Max to 0 loop. Yeah, because here v minus 1. That's pretty neat. So this is the same thing that I did just the other way around, because I find all the positions that have them, all the rows and columns, you do it the other way around. Which is, I think, slightly neater solution. I think mine is a little unclear if you look at it. Because I have to do this again, XX minus, and that's a bit clunky. It's not great. And then you do some distances, galaxies, empty x, empty y, and then 2, which is just your expansion factor. When you have more than 2, yeah, you get hop off 1. You take the distance between that and everything else. Yeah. Magnitude minus 1 plus, yeah. The distance. Oh, so you do that here. You don't even make an expanded map. You immediately count it on. That's actually, I like that. It's pretty clean. The count empty space just does if it's between the two, you just count how many empty space slots there are between the two using a standard min-max. And some till recursion at the end. I mean, this is the same thing. I mean, I would have just made this a bit on its own, but whatever. It cleans up the splitting a bit, I guess. Oh, but you already do that here, so why not just do that there? When it's part of an expression. I don't know if the compiler actually splits it apart. No, it's not. No, it's definitely not. Not gonna stack. Oh no, exactly. It would never will. I mean, there's maybe, what, a few thousand galaxies? Even if it's a million, it doesn't matter. It's not gonna do it. Because you have an, I mean, it's Owen square, but it's like a fairly memory efficient one, because you pop off one, you iterate, discard it, and then you go to the next one, because you just keep track of the distances that thing contributes, so it's gonna be fine. No, neat. I like it. Oh boy. Oh yeah, so let me push this real quick, and then I'll tell. So last week I was super fucking busy. One of the reasons why I couldn't do Advent of Code was because I had a course that ran every day from 9 to 6, and then I had stuff after. And some days I even had more stuff to do, like my concert on Friday and an Olympiad on Thursday. But the course was weird. So it was supposed to be food analysis. So the idea was that we learn about how to analyze food with various methods. And we had a very, very brief amount of what I would find interesting. Like, for example, whatchamacallit, microscopy, NMR. Very little of that. And then a ton of mass spectrometry and chromatography, so liquid or gas. And it was just kind of ass. Like, hearing the same things over and over and over again, it doesn't help. Like, oh, now we're doing mass spectrometry on milk, or on a slightly different system. It doesn't add anything, right? Like, if I know how mass spec works, which I already did, this isn't going to add anything. Like, it's a lot of metabolomics, proteomics, like figuring out what proteins are in there. It's like, I don't care. I don't need to know. Which is fine to have 1 or 2 lectures about it. We had like 10 or 12. It was like 3 days were fully mass spec. That's just asinine. And we had also a presentation where someone had to do it online. It's like, it's fine, like, whatever. But their presentation was given as if everyone had the screen right in front of them, like it was given on Teams, or like an online Zoom meeting, because I just couldn't read shit in the back. Like, yeah, I know I need new glasses, but everyone else I could read just fine, and this person, their presentation was unreadable. They even had like the good old, I'm putting yellow text on a white background, or like light blue text on a light gray block. It's just unreadable shit. It was impossible to get around. I put it in the feedback as well. I was like, vet the fucking presentations beforehand. Like, you cannot have this in a course that people pay a significant amount of money for. Let alone the fact that 10 people sort of re-explain what mass spectrometry is. It's like, oh, we need higher resolution. Yeah, of course we do. It's good. Like, one guy actually gave a somewhat useful presentation and showed, okay, this is why we do these things, why they're relevant. I love that. It was about differentiating between Chinese star anise and Japanese star anise, because the Japanese version has a neurotoxin in it, and the Chinese version doesn't. So Chinese is used for food, the Japanese one is used for decoration. And the only way to figure that out is by using a very high resolution mass spec, because the weight resolution you need to actually discern that neurotoxin peak is very, very high. So you need a very good one. And I love that. That was a good example. But people going on and on and on about, oh, when we do mass spec, we get this massive list of fractions. And we chuck a library at it, and it doesn't always work. It's like, I could have told you that. And I don't even use mass spec anymore. I haven't in years. Go and pose it, I'll answer it when you ask it. I'm surprised so many people don't know. Yeah, it's insane. Star anise. Like, you know. Like star anise. Like this stuff. And so, Chinese, you can eat it. The Japanese, please fucking don't. You will die. Okay, you won't die, but you'll be, you know, it won't be fun. Chocolate library. Yeah, but like, oh, it's in a lot of other things. A lot of other foods that are like wintry, like spicy. They have that in it. But having 6 presentations about we chuck a library at it, it's just not very useful. And they have a guy from corporate, from like a company that makes them, telling you the exact same thing. It's like, I'm here to learn about food analysis and not about what a guy does in his daily job as a mess spec tech. Like, it's interesting, but it's not why I'm here. And it's just, it's a very frustrating thing that I am extremely, well, I want to say extremely busy while I'm sitting here doing Advent of Code. I finished for now. This is my last working week. I'll probably be writing a bit over my holidays as well, because I want to get my fucking draft done. This is me actually fucking relaxing after a week and a half, for once. That's not entirely true. I did some fun stuff over the weekend, but it's, you know, during work hours, not actually sitting in the benches and getting useless information thrown at my head. It was a very frustrating week. Because, you know, seeing, like, you know, okay, we paid money for this. It's somewhat interesting, but it's just far enough away from my field that I just don't really care. And then the one time that a guy actually starts talking about infrared spectrometry, which is imaging, it's a dog shit lecture that I've also heard half of it before. It was so fucking frustrating. Because the guy was trying to sell us cheap €200 infrared sensors when we're all students there, PhDs, who aren't working with crap. We want to do actual high-end characterization. Like, if you go to the industry people, or you go to, say, the people who work on the agriculture side, yeah, they care. They really want stuff that can work in the field, that, you know, it has to be waterproof, it has to be reliable, it has to be low service, low maintenance. But in the lab, we don't care. We want to know very precise information. So when the guy comes over and goes like, oh, you can characterize a cheese sandwich with a €200 sensor. It's like, I don't give a shit. It's like, yeah, you can discern between the cheese, the butter, and the bread. But, you know, that's not that difficult. It's not that impressive. I get it's super low-end research that you have to do as well. But I'm here trying to, you know, discern sub-nanometer structure of protein, and you come at me and go like, this thing has a very shitty resolution, but you can correct for it using these funny little statistics tricks. Like, I just don't care. Very frustrating week. Singing concert Friday went fucking great. I'll post the YouTube links when I have them. I already have the audio, but I want to have the video as well so you can see me dance out of sync. Thursday we had an Olympiad, which also was pretty fun. Anyway, I'm going to go read 12 now, and then do 13 after, and then go to work. You finally reached for hot springs in a secluded area section of the primary order building. I thought you were looking for the hot springs. This is actually the onsen. Oh, it's the same thing, right? See? Same thing. A massive metal helix is towering overhead. Are you playing Pathologic? Takes a few more steps to main gate. We're having a lava shortage. All of Gear Islands. Oh, I like this. Springs are very springy unless they're hot. That's fair. Nothing is being manufactured in the mode. Nobles to get more lava to heat our forges. So we have to wait. The springs are not too cold, but you should be able to find one spring enough to launch you up there. Ironically, when they're colder, they're stiffer, so they will actually work better. Many of the springs are falling into disrepair. So which one are even safe to use? Where's their condition records of which springs are... Their condition records... Wait, what? Their condition records, not... yeah, of which springs are damaged. You'll need to repair the damaged records. That's a little... cyclical. For each row, the condition records however spring whether it's operational or damaged. This is the part of the condition. Wait. So, for each row, the condition records show. Okay. I keep reading records as a noun, as a verb, and not a noun, and it doesn't work in my brain. Every spring and whether it's operational or damaged. This is the part of the condition records that itself is damaged. For some spring, it is simply unknown. Yeah. So duplicated some of the information in a different format. After the list of springs, for example, the size of each continuous group of damaged springs is listed in the order these groups appear in the row. The list always accounts for every damaged spring, and each number is always the entire size. So condition records with no unknown spring condition might look like this, yeah, because we have 113, 113, 1316, 411, 155, 165, 321. Okay, yeah, so we know that because it's 1-1, it's B1, yeah. Fit the given criteria. There's only one way. Okay. The first and second must be... Okay. Oh boy. Just gonna take a quick look. Ha! This looks like an interesting problem, I like it. So this is more something like a mapping. So for this one, you would kind of strip off what is fine. So this would be a dot 3. So you remove the last dot 3. Same here. So you would say you remove the last. You probably just remove all the first starting and end dots because those are completely irrelevant. And then we go here. Okay, we have then we split by dots to get all the. So this is one of those things that by hand is super easy to solve because your brain is actually really, really smart at these sort of pattern recognition problems. Because you will immediately see, okay, this has to be part of a 6. So at least this one, 1, 2, 3. All the inputs by hand, I'm not going to. Because the block of 5, these have to be dots for sure, and this can be either shifted here or here. But if it's here, it'll be a block of 7. So it has to be D6 with a dot here. I can tell you that my code for part 1 couldn't finish it. Oh, it's probably like something much more complex. Oh boy. And probably a lot more permutations. So one thing you could do is just pure mutate everything. I'm going to take a quick look at the input because I'm pretty sure it's like how many questions you ask. So you could in theory say, this is actually, this one is a pretty good example of it actually. So you could in theory generate every single permutation, which would be 2 times, 2 to the power, it's like a few thousand. And then just check every single one and see if it fits. That's the lazy way. And this will always get you the right answer. However, it is extremely slow. I tried running part 2 on the Unity computing cluster and couldn't finish it like 2 hours. Oh my god. Did you multi-thread it properly? Because that feels weird. And that sounds very funny though. I wonder if I could do that. Could I do that? Well, we're going to get a bill for that, so I'm not sure I should. I don't know. How big is your computing cluster? I assume it's fairly big. Because we also have a pretty big one. Yeah, no fucking wonder it's not faster. If it's all single-threaded, like, a cluster isn't going to do it. I don't know if Fortran has multi-threading. I assume it does have something, but I don't know. Because in theory, this is, like, unless there's cooperativity between the lines, this is an extremely multi-threadable problem. Because you just chuck every single line in a separate thread and tell the scheduler to figure it out. That's what I would do here. I mean, we have Blades with a few thousand cores on it, so it'll probably solve it in like second. I'm not gonna multi-process this. I mean, it's probably... I think it's not actually too difficult to do in Python. I can tell you part 2. No, I'd rather not. One for each line. Yeah, I mean, it works. Because you could, in theory, spawn a separate process for every single line. Yeah. No, I'd rather not be spoiled. I'll look at it later, because I'm probably going to do this. I'd like to do this the mornings of every coming day to do at least 2 days. Didn't work, though. So, the smart way that you could do it is by first getting rid of everything that's guaranteed. Because this is 6 and 5, so this would, by definition, get struck off. And then you say, how many times does 1 fit in here? And there's 4 ways. Someone at work implemented multiprocessing to call a REST API about 5 times at once. Nice. Doesn't that just, like... I don't know how networking is handled in the case, but it feels like that would just cause a... some sort of DDoS protection to kick in. I don't know. Was this a mission I need to look at? No, later. Okay, but so here, you know, there's 1, 1, and there's only one way for that to work. Is actually the first line of test. Oh, Jesus Christ. Interesting. What if they were all question marks? Is that going to be the question? No, because even for the first line, that only produces a few thousand options. So here, so this is a guaranteed 3, so there should be a way to, yeah, such a thing. Oh, that's true. That's basically this, yeah, and this as well, so that's not going to be it. Do we have one in, no, we don't have one in the actual, but it's close. In real input, not test line. Oh, okay, yeah, fair. So here, so there's 2 parts to every single one of these lines. One is splitting apart the stuff you know. So this will be a very simple reduction. Go like, okay, we need 3. Do we have already a block of 3 at the start? Actually, no. There's a different way you need to look at it. You need to know if there's already a guaranteed block that is fitting it. So you would start from top to bottom. So 6, we know there's a 6 in there guaranteed, so we just like remove that from the entire line. So take it apart, take the dot apart at the end, then repeat again. Do we have a 5? Yeah, we match a 5. Remove that again, we're left with a 1 and these question marks, and then you can do some... I think probably here you can like reduce the problem down with a few if statements, maybe? You'd have to account for a lot of options, but in theory it should be possible. For here you'd go, okay... so here you'd go, we match a 3. So this must be it. So this would be a dot at the either end, because it can't be any of these. It's impossible. And then you're left with this, and then you have, you know, how many times can 2 and 1 fit in here, and then you just, you know, you solve that problem. For here, you go, okay, we don't have a 3, but we have a 2, which is also still higher. Maybe you can like map all the blocks. You know, like this is a 2, which can't be any of these, so you have to do it like this. I can see why people would just do pure mutations here and see if they fit. That's probably what they're actually going for. As like the, oh, this should be the easy way to do it. I'd like to code the more complex one, because I think it could be fun. And here, so this is the really questionable one. How would you do this? How would you solve this line in a clever way? Because this one's not even that difficult, because you go, okay, we have a line of, what is it? 7 unknowns. And you basically have, because there's only 2, you can always go like, okay, start here, 1 can go here, 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 or here, shift over the 2, can go here, 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 shift over 2 again, until, you know, it doesn't fit anymore. That's in theory a fairly simple process. Which is like O(n) log n, something like that, which isn't even that bad. Here, this one is the one that I'm fairly curious about how to properly solve it, because so we know this one. So here, what you would do, you know, this one needs to be the first one. So you just like you go from the left and from the right, so you can do this twice. So you go like, okay, what if we? So this has to be dot hash dot. Because if it's hash hash or hash hash dot or dot hash hash, it'll be too long. So with 1, that's a nice case. If this was a 3, it could be either this, but this one, it have to be like this. So I think, yeah, and that's the way you would iterate that. So that's probably a few ways. So I guess that this would just be a recursive problem where you every single time try the same things. Slash from the start, slash from the end, see where you end up. And that will be deterministic. And then you're left at the end with the random part. Because here we know this needs to be a 1. And this then needs to be a 3. And this needs to be a 6. And then you know this is dot. So this is actually fully deterministic, right? Yeah. It's one arrangement. Okay. I think I've got a way to do it, but we'll see later as to how much it works to this symbol. Alright, let's do actual day 13. Yeah. Okay, yeah. I'm a lava island, but I don't see lava. I see a lot of ash in igneous rock. It looked like grey mountains cut around. Close mountains full of a valley between us, completely full of mirrors. Seem to be aligned in a consistent way. Person can head in that direction. As you move through the valley of mirrors, several of them have fallen from the large metal frames keeping them in place. Extremely flat and shiny, and many of the fallen mirrors have lodged into the ashes strange angles. The terrain is all in one color. It's hard to tell where it's safe to walk or you're about to run into a mirror. For example, perfect reflection goes either a horizontal vertical line between 2 rows or across a vertical line. 2 columns. Yeah. This is pattern. Perfect in the middle of the pattern. Part of the pattern's note to reflection can be ignored. Ah, okay. Every other column is reflected within the pattern. Would reflect per the hypothetical row 8, but since on okay. Yeah, so it's just a way to characterize where you have it. Okay. So they should be like little blocks, yeah. Hey, did it properly for one sort. Day 13 tests. Day 13. Actually don't need to do that. Input slash 13 dot read dot split on slash n. And you like, yeah. There we go. So horizontal is kind of easy. And then I think I might just do a transpose. I just do it the other way around because you would just check if they're equivalent. So you basically have a mirror line. So let's say let's do continue at the end. Blocks, please. So So basically we check if every, we don't. Why? Oh, yeah. So here we need to transpose and then do it again. So here, let's write a function for this. So what we do here is we do, yeah, whatever. So we check if everything is mirrored before and after. So we do like, so this will be 1. So we check if the first line matches the second line, nothing else matches, that would then be a mirror plane. How do you do that? So we just need to get a before and after, which is easy, because that would just be block. Because this is a list of lists, a string, actually, list of string, like this. Because then we do block till y and block y after. Can the mirror plane be inside a line? Is it always in between? Perfect reflection with other horizontal line between 2 rows or between 2 columns. Yeah, it's always going to be the same. And then I just need to reverse this. And then just check if like the lines are identical. So then we do for I in range y. Actually, we can do something like all. Actually, much easier. And what do you mean? Over L over indented. Yep, there we go. Why are you still complaining about unreferenced Y? What? Oh yeah, oopsie. There we go. And so here what I could do is I could transpose it, which would just be how can I easily do that? Transpose list of strings. Oh, wouldn't this just be zip? Yeah, I was about to say you can just use zip here. Else. Here we go. Find plane zip locks. There we go. Because this just flips at 90 degrees and just goes for the columns. Dun, 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 dun. Okay. Oh yeah, it doesn't do automatic typecasting. There we go. Haha, haha, ha, uh-oh. Interesting. So we know for the first one. Okay, Okay, for the second pattern, it's a horizontal line. So, because the flipping obviously doesn't work properly. Oh yeah. The only thing is, technically, you should just only do it once, and not keep doing this because it'll keep flipping it, and this, it just, I guess, it doesn't work. Let me just copy this. Do b equals blocks 1. Oh no, this is not the one that needs to be flipped. And I want to do this real quick. Oh, definitely, because this is block. Whoopsie. Alright, let me actually just refactor to the rename to B. Yeah, so just maximum recursion depth. Yeah, B is now the first one. Ah, yeah. But this should still work, I'm pretty sure. Name direction not defined? What? That's weird. Right, so B is, so Y is 1. Man, I'm terrible at this. Jesus Christ. There we go. So I just did a breakpoint there. So yeah, so we know it's right here. So it, like, what is it? Y equals... Did we already flip it? What? Ah, no. No. So this is the wrong way around. I would like to see when it is transposed. 6. Okay, and now it should be transposed, yeah. To... So it would be not here, not here. Wait, what? Am I doing my mirroring wrong? No, because the plane is here, this should be equal to each other. Oh, I think I kind of see what I'm doing wrong. So here... Wait. What the fuck? Because we're here. Yeah, it should be... What am I doing wrong here? So hash dot hash hash dot dot hash, yeah. Dot dot, yeah, that's all correct. So then we need, in the end, dot hash dot dot hash dot hash. Ooh, kind of difficult to see here. Am I having a Marvin moment? What is a Marvin moment? Dot hash dot dot hash dot hash, yeah. And this is identical. This is identical, etc., etc. Okay, so it should be 1, 2, 3, 4, 5. Okay, why is the B just got duplicated? 3, 4, 5. Right. So let's say I equals 5. Then we get I equals 5. So, and then let's say L1 equals this. And then... Oh, I see. I need to reverse the first part. And not the second part. Actually, let me just do L2, come on. Because then I can edit it at the same time. Yeah, because now it's the exact same issue but in Rust. Is it because I'm already separating? Wait, no. Dot hash. Because this B is 9, and I only have 7 here. Working off by 1 errors? No. What? I'm probably being just very stupid here. So here's hash dot hash dot. That's this one. So dot to this works properly, but L1 isn't right. Yeah. Why does it start here, not here? Oh no, because I'm reversed it, so... Wait, what? Let's revise how slicing works. Probably fucking that up. So this one needs reversed. Yeah. Wait. Am I fucking up my slicing? Does it reverse then and then do the dash I? Because now we get everything. Yeah, hash dot hash hash dot dot hash all the way up to dot hash dot dot hash dot hash. Do I then just need to do like this? That would be very disgusting. Yeah, but that does work. What the fuck? For I in range. But now I need to... Wait, why? Yeah, I need to remove you. There we go. I think the order there is different. Then what I want to do is I need to limit them. Because it's going too far. Because, if it's 1, we want this to be at most a certain length. Which would be Y? No. It would be like the maximum of... yeah, it's the maximum length it could be, which would be like, wait, what am I doing here? Why am I doing for range Y? Oh, I am so dumb. Good fucking god. Like this. You idiot. Because I should just get a single one. This is nice, but stupid. This is a terrible idea because it reverses it every single time. Because this would actually, it's actually kind of a better idea. So let me actually do this, but we rewrite it. Because what we can just do is... So what I could do now is do L1 equals L2. Should be false. Oh. Why the fuck? No. Why would you do that? Why does it say error result is none? Oh. There we go. True, yeah. Of course, because I'm an idiot. Oh, I don't doubt it, but I'm just trying to do it in a dumb way. Because I like this way. So what I need to do then, you know, L1 equals L2. Ooh, that'll be false. But then what I need to do is do like a limit until what would it be? Min then B minus Y. Should be 4, yeah. Oh, yeah. Oh, and then we just do... Yeah. Here we go. Disgusting. And this should be Y. Five and 4. Okay. After 5, after 4. All right. How do we actually number of columns to the left of each vertical line? Availability level 0. Ah, shut up. It's perfect. Add the number of columns to the left of each vertical line. The number of rows. What? 5 to its left. 4 rows above it. Add the number of columns to the left at 100 multiplied by the number of rows above each horizontal. Okay, yeah. So I need to also know if it's horizontal or vertical. So we always start with 1, which will be like, or true or false. I'm not sure. This is reading comprehension. I don't like reading comprehension, man. So should we do horizontal? Just flip it around. So this should be mirror, comma, horizontal. If oh. I'm like 100% sure I'm gonna fuck up something here in the 9. Nice. The fuck you doing, bro? Just this. Technically, it's a plane. When are you finding this? Oh, what is like... Oh, yeah, of course, you know, why not? 504. 405. Huh. will be very surprised this actually works. Falsely 0, yeah, but I want to flip between the two. I mean, I could just make it a bool. But technically it could flip between the two. It should never do that. It should never... Actually, I could just do it like this, make it a bool. This actually would be better. Because then I can do false. I do if plain. And then all I need to do, what can I do here is like if horizontal, if not horizontal, raise our exception bad. And then I need to, well, let's do it like this. It's cleaner. All right, let's see if it's correct. Smack, run directly on how many I was watching. Is everyone exact one smudge? Exactly one. Oh no. Might have a different horizontal line of reflection. Row 1, so there's no. Okay. Oh no. So I need to basically check the differences and see if it's exactly 1. So, that's a fucking pain with my solution. Jesus Christ. So what I do is I check the differences. Oh, fucking hell, no. Okay. So what I simply need to do is I need to get through pairs. So I already have my lists here. So so let's do like L1 equals this and L2 equals this. And then I just need to go through the pairs of them and go like deltas. 0. So we simply do for we just need to zip this. So we do for whatever for pair in zip L1, L2. So now we get every line that we would need to compare, and I simply check if there is a single. Yeah, I just okay, Prince pair. I want to quickly see what this becomes. Oh yeah. Part 2. Oh yeah, I need to click this one. Here we go. So we'd get something like L1, L2. And then I simply go, yeah, so this will be S1 and S2. And then we just do, what if I zip these again? So S1, S2 equals pair, list, zip, S1, S2. Yeah, so we just, for C1, C2 in zip S1, S2. If C1 is not equal C2, deltas plus equal 1. And then you just do if deltas equals 1. $400. That's correct, right? Yeah. Okay. Yeah, I know you can't see it. That's the right answer. Hey, I'm very happy with that. Check the leaderboards real quick for that. Day 13. Ooh, Dennis was faster. Nice. Well done. I'm not sure what the delta is up to here, but it's not bad. Let me clean this up a bit. Okay, we don't need to remove you. Because... Oh, there we go. Clean this code up a bit. One second. Okay, give me a sec. I don't like this duplicated code. It's clunky. It's just a different function. All right, let's do something very funny. There we go. That's how you reuse code, baby. Seconds. Let's see. So we can generalize this code by having a sort of like accepted deltas. Seconds. Yeah, so we like deltas, delta limits. This would just be find plane. In 0, 1. What? Oh yeah, here. There we go. By a whole minute. That's what you get. That's what they get you on. Is this clunky? I mean, I could just clean this up a bit. This solution is rather okay. I think there should be a cleaner way to do this, but zipping everything together in various ways, it works. This, I guess we don't need anymore. We also shouldn't need the else, because this can just work like this. Your solution isn't bad enough. I'm sorry, I can like code something somewhat well. Doesn't happen often. This you can probably make a comprehension. Too short, ergo it's bad. No, let's make it shorter. Sum. Duh. List comprehension. Mirror lane in find plane. And oh, this needs to go here for sure. Well, this needs to be a 4 block in blocks. Because every block we get 1 mirror / pane. This gives us pairs, so yeah, that doesn't work, but I can do it like this. P0 if P1 else 0 in oh, damn it. No, because this like this gives me a list of all of them, then I need to reduce this again, so I need to call another function that basically does this. Because I need to do an assignment and then logic, and I don't think I can do that. Because this gives me the iterator, which is block. This thing gives me the answer, which is the mirror / plane for every single block. Which would be something like what does sum do with nested lists? Yeah, doesn't work because it's just a reductor. I think I could do something like do another bit of a nested list stuff. So in theory, this is a list, and then reduce some. Yeah, no, I could do it. You'd have to do a little bit of extra logic, but I think I can do it because this is a individual list, and then you could of course do more nesting because we can just get so can you do like this? But no, because I don't have an hour left, but this is what I'm gonna finalize here. So this we can do mirror times 100 if plane else mirror 4, and then I just need to here just grab the 0th element. Oh, yeah. Hell yeah, baby. This is disgusting as fuck. No, shut up. It works. It's a one-liner. I love it. You were joking. Oh, I'm sorry I couldn't tell. Perfect. It's 22 lines. Love it. Let's commit it. And then I'll take a look at what Hamster shared, and then I'm gonna do some actual work. Day 13. Imagine writing maintainable code. Kind of pathetic, to be honest. Symmetry search. What the fuck is this? Alright, answer 1, symmetry memory. 4 tests and tests. There's a line, is line, list line. You know you don't need to do that. You know, strings are already lists. And then you first construct it. Yeah, so zipping is very, very nice for that. They are not. I mean, they're strings, but you can pretend they're lists. That is true. They're not. Yeah, but you shouldn't need to modify them. That's true. They're more like the tuples, I guess. They're just immutable lists. Yeah, no, they're tuples. Have you read part 2? Yes. Turns out you don't need to mute. What do you mean? Because I did it without modification. I just count the differences between them. There's no need to actually modify them. Sounds lame, man. Sounds like you're a bad programmer. You get the symmetry search. You just check if it's 0. Yeah, which one's... yeah. There's the value. What do you do? System memory... symmetry memory append. Oh, because you keep track of what's already symmetrical. I'm also a paid programmer, technically. I'm just not paid to program, I just do programming as well. Your symmetry search. What is old symmetry for? Your job title? No, it's true, it's PhD. I want to say all. I mean, I know you also were one. So once I get my doctorate, then I can get back at you. Then I'll get a programming job and I can say I'm a doctor programmer or some stupid shit like that. Anyway. For every line, if line equals the next line. And if I is not even -1. What? What is this variable for? I'm slightly confused. Oh, you do actually use that later on, so I guess you just repurposed it. Yeah, that's what I realized. That's why it's -1. So count is 0, flag is 1. Checking that I didn't find the same symmetry. Oh, that's why you also keep track of it here. But so while I plus 1 is kind of less than length of lines, yeah, just to make track, you only keep track of what you want. If and then you see if it's asymmetrical. Yeah. Break out, and then if it's 1, you do plus times the factor. Because I is 0 indexed, yeah. So I do it the other way. I was like, why do you need flat, but you do it the other way around? Is it just like it's symmetrical, we assume, then if we see an asymmetry, then we break it, we're done, and then we can return 0, because we know that this isn't, we break out of it, yeah. It's all fair. I mean, this should be a raise exception, but I also removed it in the end, so this you could in theory remove this. Oh no, because you check horizontal and vertical separately, so yeah, you wouldn't need this. Fair. Ever part 2, what the fuck do you do? So for everything's for if you change the single one and then you flip it back. Oh my god. I don't understand Nitro's Day 13, not gonna lie. What do you don't understand about it? I don't mind walking through it. Oh, that's a lot of colors. Good god. I find this painful on the eyes, to be honest. They do some similar bullshit to what I do. I can... Oh, why the hell does it do that? Oh, because I updated... I find your IDE painful. It's nice and grey. All is mostly white. I mean... Fair? I quite enjoy it. And an ugly font. I disagree there. I don't think your font is, like, bad. Oh, the man uses NumPy! Ah, plus point and laugh. 50 lines. 22. Looks probably... My man's working in a text editor. Programming in numpad. Sorry, I mean notepad. Of course. I mean, what I basically do is I basically go from, so this is what you need to know. So this will be a list of strings. This will be a block, horizontal to vertical. Doesn't really matter. Delta limit is how many differences we are looking for, which is 0 or 1. So this y coordinate is basically which line are we checking. So it goes from 1 all the way to, well, the end minus 1, basically. Because the 0th line can never be symmetry, because that's impossible. This is the length that the mirror block will be. So if it's the first line, it'll only ever be 1 line long. Second line will be 2 lines long. It just basically gives you that triangular shape, you know, like this. Because in the middle, it's the highest, and then afterwards we want to go down again. Delta just keeps track of deltas, and this block gives me first how many lines do we want? So this is the first part of the block, first part of the mirror. Then we reverse it, and then we limit it again. Because if we're over, say, if we're 3/4 of the way through, we then want to limit it again to L. So this could, in theory, you know, this just does take the first batch, mirror the whole thing, and then limit it again so we have the exact right amount. And here we do the same thing, but then at the end, but we don't need to mirror it. So if they are mirrored, this is identical to this perfectly. But then because we want to know how many deltas there are in these blocks, we first zip every single one of these. So then we grab every line pair. That's what this does. So this gives me the first line that should be mirrored, then the second line that should be mirrored, the third line, fourth, etc. And then I compare every individual character inside these by using zip. And then if they're not equal, I just add the delta. And then if they're equal to what I'm looking for, we return. So if there's a single difference, then it's 1, and then we return the answer. If we're looking for 0, then we have 0. And then what I do at the end is, okay, if I didn't find anything, then this just mirrors, just transposes it. because it puts every single string after each other, takes the first element for every single one, the second element for every single one, yada yada yada, puts it into a list. I have to do this because length doesn't work on a generator, doesn't have a length element, and we flip the horizontal to 0 also because that's what we base this bit on, times 100 or not. I think it's a fairly elegant solution. I could do something like if delta equals 0, just compare these two, but that adds more code. This is slower, but it's not significantly slower. I still didn't get it. I mean, what's the part you don't get? This is the one confusing part, I agree. I don't like it either, but it's a quick way of doing it. Deltas? Basically, we check for every single character if they are identical or not. Basically, we put every character that, if the mirror... Don't understand the con... I just count in... If we check it, if we have any mirror plane... Yeah, if it's a block, and this is, one part, and this is its identical reflection, there will be 0 differences between the two. If I have the plane in a different line, there will be tons of differences. Like many, many, many of them. But part 2, because it's about smudges, there should be only a single difference between the two. And that's how I can do part 2 rather quickly. Or how it wasn't a ton of time to modify it. It just counts how many differences there are. If it's mirrored, there's 0. If there's a smudge, there'll be 1. Or sorry, if it's the mirrored smudge, there'll be a single difference. If they're not identical, there will be a ton of different ones. And then I can just... Then I maybe I read part 2 wrong. Could be. I mean, yeah. 4 minutes. Hour and a half. I mean, Hamster's solution was clunky, but it was not the slowest by far. But yeah, 2, 4, 6 minutes. Well, 5:40. Still pretty good. Here we have, same thing here basically with 11. 1 minute, 2.5 minutes because I'm pathetic. I beat Dennis at least, that's good. Keeps our deltas here identical. I wish I could track it up until, because I'm pretty sure I'm still ahead of Dennis where I am now. Although he is 1, 2, 1, 2. Woof. That might be tough to beat. I think 12 might be... That's going to be an interesting one there. I will see. I'm not too worried. I would like to beat Dennis there and, well, everyone else, but we'll see. It also depends on where the other people fill in. Because if fewer people join the days, it's going to be easier or / more difficult for either of us to be ahead. Me being a bit slow. I hate this graph, it's so shitty. So these are all not very useful. Alright, I'm going to call it here. Thank you all for watching. I'm going to see if I can do 2 more days tomorrow. We'll see though. So thank you for watching, and I'll torture you later.